हेलो। आज हम सैम्पलिंग के ऊपर एक क्वेश्चन सॉल्व करने वाले हैं। तो आइए देख लेते हैं कि क्वेश्चन में क्या दिया गया है। We are given two random variables and both are uniform 0, 1. Now z is the maximum of x and y and w is the minimum of x and y. Now we have to find this particular probability, that probability z minus w is greater than half. Okay, तो चलिए इस क्वेश्चन को सॉल्व करने की कोशिश करते हैं। Given that x is uniform 0, 1, so as y, and they are independent also. Therefore, the joint PDF of x and y is nothing but 1 whenever x and y is in between 0 to 1 and 0 otherwise. Now, as we know, if we have x curve which is x1, x2, xn follows uniform 0, 1 and they are IID random variables, then the joint CDF of maximum and minimum of xi is nothing but probability of x order 1 is less than equals to small x and x order n is less than equals to small y, where x order 1 is the order statistics denoting the minimum of xi's and x order n is the order statistics denoting the maximum of xi's. Now this reduces to probability of x order n is less than equals to y minus probability of x order 1, x order n in between x and y. Now as xi's are IID, so we can write probability of x1 less than y whole to the power n and probability of x1 is in between x to y to the power n. This is the general formula for x order 1 and x order n. Now, in particular for this problem, we have only two random variables named x and y. Therefore, the joint CDF of order statistics for xy is nothing but y square minus y minus x whole square. Therefore, the joint density for the order statistics of x and y is nothing but the partial derivative with respect to x and y on f of x order 1, x order n, where n is equals to 2 xy. So we get del x 2y minus 2 into y minus x, and next we have 2. Here x and y is in between 0 to 1. Now take a transformation from xy to mn. Okay, where m is y minus x and n is just y. So from this we can imply that y is equals to n and x is equals to n minus n. As x is greater than 0, so m is less than n. So we can write that the range of mn is also 0 to 1 and m is less than n. Now we have to calculate the Jacobian of the transformation. Now Jacobian J is equals to del x del m del x del n del y del m and del y del n. So it is nothing but determinant of minus 1, 1, 0, 1, which results in minus 1. Therefore, mod Jacobian is equals to 1. So the density of order statistics reduces to f of mn, which is nothing but 2 into 1, where 1 is the Jacobian, and the range of mn is like this. So the marginal density of m is f of m, which is nothing but we have to integrate f of mn with respect to n, and the range of n is m to 1. Sorry, here we do not have 2 because we already write 2 here. So we get 2 into 1 minus m, where the range of m is 0 to 1. Now basically this can be written as 2 into m to the power 1 minus 1, 1 minus m to the power 2 minus 1. Therefore m follows beta 1 comma 2. So maximum of xy minus minimum of xy follows beta 1 comma 2. Now we have to find the probability z minus w is greater than half, where maximum of xy is z and minimum of xy is w. So we have to just integrate uh, this PDF 2 into 1 minus m on the range of half to 1. Okay, so we get 2 integration half to 1 dm minus 2 integration half to 1 m dm, and this is nothing but 2 into m half to 1 minus 2 by 2 m square half to 1. Therefore we get 2 into 1 minus half minus 1 minus 1/4. So this is nothing but 2 into half minus 3/4. Okay, so we get 1 minus 3 by 4, which is 1 by 4. Hence the right answer is option 3. So we have solved this problem, and that's all for today. Thank you very much.